Hey students, welcome back. Today we are going to learn about angle relationships and circles. This is found in section 10.5 of your textbook if you'd like to follow along. So there's I organized the material into three different cases. The first case is when the angle is on the circle, and that's kind of a carryover from the previous lesson that we had with inscribed circles or inscribed angles. The second case, number 2, is when the angles are inside of the circle. And then the third case is when the angle is outside of the circle. So on the circle, in the circle, and outside the circle. Okay, here we go. Last time what we learned is, remember we had this very nice presentation that I put together on inscribed angles. And so we learned a lot of key terminology, and there was one really major theorem that we learned. There was two actually, one about congruence, but the really breakthrough one that we learned was the very first one. Okay, and it was this situation here where you have a circle, circle C, and you have an angle, angle ADB, and that is an inscribed angle, meaning the vertex is sitting right on the circle. And we learned that there's a very special relationship with this angle, angle ADB, this inscribed angle, and the arc that subtends it, arc AB. And what we learned is that this angle, this measure, is half as big as the arc that subtends it. Okay, so we're going to build on that. So how do we calculate the measure of the inscribed angle? It is half. The relationship is this angle is half as big as the measure of this arc. So let's go ahead and add on to what we learned. Okay, so ignore this red line for just a moment. Okay, but you have circle C, and then you have angle ADB, and we know that angle ADB is an inscribed angle, and it intercepts arc AB. And so the measure of angle ADB is equal to 1/2 the measure of this big arc, arc AB. Okay, well, what if we took that? Okay, and notice that the angle, the inscribed angle, is on the circle, and that's our first case. Okay, what would happen if we stretch side AD? So if we took this yellow side and we stretched it, and we didn't, we pulled it out here, and you can see that that's going to open this angle up and make it bigger. In fact, we're going to stretch this so much that it becomes tangent here. Okay, so we stretch it out here. Okay, and now A gets pulled to over there. And we get rid of that. So now the angle is over here. Okay, so now here is angle ADB right here, this big angle right here. Okay, and you can see that we've made that angle bigger. Okay. What's really fascinating is that the relationship actually stays the same. So the measure of this huge angle, angle ADB, the measure of this angle is still 1/2 the measure of the arc, this big arc here that goes all the way around. Okay, it's still a 1/2 relationship or a 2-to-1 relationship. We can also extend AD on the other side, and that is this that I drew. I forgot to animate it in the right order, but that's this. So if you look at this, this is a straight line, okay, and it's tangent to this circle. And then now in here you have a secant, or actually part of a secant, you have a chord, right? So you have a tangent and a chord. Okay, so this angle right here, the relationship is that its measure is 1/2 the measure of this huge arc. Well, the same thing is true, the same thing is true over here. This angle BD, and there's no letter over here, but this angle, this smaller angle here, its measure is also 1/2 of the measure of this arc over here. So the relationship is a 1/2 relationship, or a 2-to-1 relationship, however you want to look at it. Okay, and that is really our first case. Our first case is where the angle is on the circle. Okay, and so you have the circle, okay, and what do you have? You have a chord and a tangent, okay, and they hit at one point on the circle, point A, okay, and so this big angle here, angle 2, the measure of angle 2 is equal to 1/2 the measure of this blue arc, BCA. And then this little angle over here, the measure of angle 1 is also 1/2 the measure of this arc right here, this red arc, arc AB. Okay. Okay, so let's go ahead and do an example on that or two. Okay, so here's our diagram. Okay, we have this circle, this unnamed circle, and we have an angle that's right on the circle, right? And we want to know how big is the measure of angle 1, this red angle right here. How big is the measure of angle 1? Well, they give us that this arc AB, measures 130 degrees. Okay, now let's just think about it for a moment. Does this angle look like 130 degrees? No, it's obviously not obtuse, it's acute. Okay, and so that should jog our memory that, oh yeah, the relationship is 1/2. 1/2. 1/2 is a key number in these relationships. Okay, so 1/2. So this angle measures 1/2 the measure of this arc. So here we go. Measure of angle 1 is equal to 1/2 the measure of arc AB. Therefore, plugging in 130 degrees here, we get 1/2 of 130, which is 65 degrees. Easy peasy. Okay. Let's go to a little bit more complex example. Now we want the measure of arc KJL. 3 letters, we know it's going to be big. It's going to be bigger than 180. This is a major arc, so let's locate that. It's this red arc right here. K to J to L, that's going to be a big number, right? And so we're given that this angle right here that is subtended by this arc is 125 degrees. Okay, so if the angle is 125 degrees, what do we know about the arc that subtends it? It's going to be twice as big as that, right? And so that means it's going to be 250 degrees. Okay, case 1, done, in the books. Case 2, angle inside the circle. So we covered case 1 where the angle is on the circle. Now we're going to move that angle inside the circle. And here's what it looks like. Okay, if 2 chords intersect inside a circle and the measure of each angle is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Okay, so what the heck does that mean? Okay, look over here at the diagram. We have the circle, unnamed circle. We don't need the center. We don't need the name of it for right now. Okay, we have these 2 angles that are created. Let's just forget about 2 for a second. Let's just look at angle 1. Okay, angle 1 is created by DB, segment DB, okay, which is a chord, intersecting with segment AC, which is also another chord. Okay, so angle 1 and its vertical angle, these 2 angles, remember vertical angles are always congruent no matter where you find them in 2-dimensional space. Vertical angles are always congruent. So these 2 vertical angles are congruent. Well, forget about the other angle, forget about all the other angles, let's just look at angle 1. How big is the measure of angle 1? What you do is you look at the 2 arcs, okay, this red arc and this blue arc, okay, and then you add those 2 arc measures together. Okay, so the measure of the red arc or the measure of arc DC plus the measure of arc AB. You add them together and then you take 1/2 of that sum. Okay, you take 1/2 of that sum. And what is that called where you add 2 things together and divide by 2? It is the average. Okay, so the measure of angle 1, it's the average of the measures of these 2 arcs. Okay, same thing is true with angle 2. Now ignore angle 1, ignore the red, ignore the blue. Angle 2 is related to these 2 black arcs. Okay, arc AD and arc BC. Okay, how do we know it's related to those 2 arcs? Because that is the arc that subtends the 2 sides of angle 2. Okay, that subtends angle 2. Okay, so you add these 2 arc measures together, measure of arc AD plus the measure of arc BC, then you divide by 2, and that's how you get the measure of angle 2. All right, so it's the average. Okay, so let's go ahead and do an example of this. All right, here we go. So find the value of x. So you have this diagram, you have this big circle, unnamed circle, and now we have the angle right here that's inside the circle, right? The angles are inside the circle. So now x is talking about this angle right here, right? And so which arc subtends that angle? Well, this arc right here that measures 156 degrees, arc KL, right? So what we know is x is going to be the average of this 156 and this thing over here, which is given as 130. So x is going to be the average of 156 and 130. Okay, so here we go. So x is equal to 1/2 times the measure of arc ML, which is this big arc here, plus the measure of KL, which is this bigger arc down here. Okay, so substitute in those values. Remember PEMDAS, parentheses come first, so go ahead and add 130 plus 156. That's 286. Now go ahead and take 1/2 of that. You get 143. Now go back at look at the diagram and see if 143 kind of makes sense visually. 143 is a big number. It's pretty close to 180, right? It's definitely an obtuse angle. Look at X and see if it represents an obtuse angle. Yes, it does. That's a very wide angle. Pow! You are doing great. Okay, we're done with the first two cases. Those are the easy ones. The third case is a little bit harder. Okay, not much, a little bit harder. But the thing that really makes it hard is that there's 3 versions of it. But don't worry, because all 3 versions of the third case is really just the same calculation. Okay, so don't get freaked out when you see the next theorem and you go, whoa, that's a lot of information. It's really just the same case. Okay, but there's 3 sort of versions of it, but the calculation is exactly the same. Okay, so case 3 is where the angle is outside the circle, right? Case 1 was on the circle, case 2 is inside the circle, case 3 is outside the circle. So here we go. All right, there it is. So angle outside the circle. Look at angle 1, it's outside the circle. Look at angle 2, it's outside the circle. Look at angle 3, it's outside the circle. Okay, so what's the difference between these? Before we get into any calculations and any mathematical, calculations, just look at the difference. What is the difference? Well, if you look at angle 1, okay, you have a secant that meets with a tangent, right? So secant and a tangent meet outside of the circle. That's case number 1. Case number 2 is you have a tangent and a tangent. So this is 2 tangents meet outside of a circle. Then here you have a secant and a secant. So here you have 2 secants meet outside of a circle. So you have 2 secants, 2 tangents, or 1 tangent and 1 secant. Either way, the calculation is the exact same. Okay, let's go to this one right here. Okay, you have a secant and a tangent. The angle is outside the circle, angle 1, right? So what is happening here? This angle, okay, it intercepts these 2 arcs, right? This red arc, this big red arc, arc BC, and it also intercepts this blue arc, this smaller arc, arc AC. Okay, how you calculate this is the measure of this angle is going to be 1/2 the difference, not the sum, but the difference. Okay, so that difference means you're going to subtract. So you're going to take this bigger arc measure, subtract the smaller arc measure, and then take 1/2 of that difference. And that is the measure of this angle. Okay, same thing over here where you have 2 tangents that meet outside the circle. 2 tangents meet outside a circle, they create angle 2. Okay, that creates 2 arcs. So there's this big red arc, okay, this major arc, arc PQR, then this minor arc, this blue arc, arc PR. Okay, take the big major arc and subtract the smaller arc, and then take 1/2 of that difference. And that gives you the measure of angle 2. Same thing over here. Now we have 2 secants that meet outside of a circle. Okay, and those 2 secants create angle 3. Okay, and angle 3 intercepts this red arc and this blue arc. And again, you take red minus blue take 1/2 of that difference, okay? And you're always taking this bigger arc minus this smaller arc, okay? Because what would happen if you did it the wrong way? You'll get a negative number. And you can't have a negative angle for the measure of an angle, not in geometry. Okay, you'll deal with negative angles later on when you get to trigonometry and pre-calculus, but for geometry, we're just going to deal with positive numbers for angles, okay? So it's the big minus the little, take 1/2 of that. Okay, here we go. Couple examples. So here's one example. Here we have one tangent and one secant. The tangent and the secant meet outside of the circle, right? And they create this angle, angle C. Angle C's measure is x degrees, meaning we don't know how big that angle is. Okay, but they've very nicely given us that this big arc is 178 degrees. This smaller arc is 76 degrees. Okay, so remember, big minus little times 1/2. Big minus little times 1/2. Here we go. So x degrees is equal to 1/2 of big minus little, 178 minus 76. PEMDAS tells us do what's in parentheses first. So 1/2 of 102, which is 51 degrees. Now, the answer technically should be that x equals 51, just in case you're curious. Here I put x degrees, so x degrees equals 51 degrees, so x, just x, would just equal 51. But don't worry about it. If you put 51 degrees, that's fine. If you just put 51, that's also fine. I'll accept either one. Just explaining in case you wanted to know. Okay, so it's big minus little times 1/2. Here we go. Next example. Now we have two secants. Two secants meet outside of a circle. They create angle A. Angle A, they tell us, measures 35 degrees. Okay, so now what we want to find is we have 100 degrees as the big arc. The smaller arc, we don't know. It's x degrees. So we want to solve for x. Remember, the big minus little times 1/2 is equal to the measure of this angle right here. So let's go ahead and set up the equation. Here it is in generalized form. So the measure of this angle, CAE, is equal to big minus little times 1/2. Okay, so let's go ahead and substitute in some numbers. So this measure of angle CAE is given to us. That's the 35 degrees. So this is going to be 35. So 35 equals 1/2 times big minus little. Big is 100 degrees. The little is x. So we want to get x by itself. Now, this is where I disagree with distributing the 1/2. A lot of you will look at this, and the first thing you'll do is you'll just automatically distribute the 1/2. I'm not going to do that. Instead, I'm going to just multiply both sides of this equation by 2 to get rid of that 1/2. Okay, so I get 2 times 35 is equal to 2 times 1/2, and so that just gets rid of the 1/2. That just becomes 1. So I have 2 times 35 is equal to 100 minus x. So 2 times 35 obviously is 70. 70 equals 100 minus x. Okay, I'm going to subtract the 70. Okay, then add the x. So x equals 30. Okay, go back and look at your answer in the diagram and see if it makes sense. If this is 100 degrees, could this be about 30 degrees? Yeah, that's about 1/3 of that, right? Not exactly 1/3, but you know. Okay. Yeah, that's about all we have, guys. So don't forget, post your questions as public comments in Google Classroom. You can also email your teacher. You can also attend the Hub. The Hub actually has virtual tutoring for math. Okay. You can also attend, your teacher might have virtual office hours. Go ahead and attend those. And good luck. I think you guys will do great on this. Enjoy the homework. Okay, you guys are almost done with the entire year. We're wrapping up here very soon. You guys have done a great job all year long. You should be very proud of the hard work you put in, especially during this shelter in place where you guys worked very independently. I know it was very challenging. Remember, this was the hardest unit of the entire textbook of the entire year, and you guys did it independently. You guys have grown and matured as students, as scholars, and you should be very proud of that as you move on into your next academic year. Congratulations. Stay safe, stay healthy, and stay awesome.